So as you can see, again, this is the lecture for kinetic equation for uniformly accelerated motion. As we have already seen, the first equation is what? B equals to V naught plus AD, right? This was our first equation, right? Now here we'll see the relation. Next one is the relation between what? Between V naught, A, T, and what? X. Okay, this is what, these are the velocities. This is what? Acceleration. Which type of acceleration? It must be what? Uniform. The time interval, and this is what? Displacement, right? So we are moving on, the find out the relation by graphically, right? So let us have a graph. This is what the y-axis, this is what the x-axis, and this is what? Y-axis. All right, now let us draw any figure as we have seen this one, right? Okay, so basically we have to find this area and this area, right? Again we have taken it as a, again, velocity time graph. This is the velocity, this is the time, right? All right, now this is the O point. This is, let's say, initial velocity, you can say. This is what you can say, the final one. Again, this is what? T. Sorry, let us name it as A, B, C, D. Okay, this is the A point, B point, C point, D point, and O point, right? Okay, so first of all, if you talk about the area of triangle, okay, area of triangle is what? Half into base into height. Okay, so what is the base? This is the base, right? And what is the distance? Is that half into base is what? Actually T. It is what? T only, right? So we can say that T. What about H? H is what? This is the height. If we talk about this, can we write it as B minus B naught? Yes or no? So we can replace it as B minus B naught. If you simplify it further, you'll get half into T times V minus V naught, right? This is the area of triangle. This is done. Now area of rectangle, let's see. Area of rectangle. What is the area of rectangle? Is what? Product of adjacent side, you can say, or you can say what? AO into DO, right? So what is AO? AO is basically what? V naught. And what is DO? DO is what? T, right? Now, so if you add it together, if you add it, that will be the area of what? Area of shaded region. Area of shaded region. That represents what? This placement, and that is represented by x, will be equals to what? Half times t times v minus v naught, okay, and plus v naught t, okay, although this is not simplified, right? So let us move on next. So what we have written, half into, what is the area? Area is, this is x actually, right? X equals to half into t times v minus v naught plus what? V naught t, right? Again we can write it as half into, okay, t is clear. Now can we replace it with some other value? Can we replace this? Yes or no? Let's see how. You know that uh, v equals to v naught plus 80, right? If you simplify v minus v naught, that will be equivalent to t. Yes or no? Right? So can we replace it with 80 here? Yes or no? So we can replace it as 80, right? Again rewrite x equals half into 80 square, we can write, or plus v naught t, right? So this is what your final equation, second final equation of motion. Okay, all right. This equation also can be written as what? X equal to b plus v naught times t by 2. Yes or no? And if we talk about this part, this is what your average velocity. So this can be also written as v dash t. Okay, why? Because this is for constant acceleration. It means this means a equals to 0. Yes or no? A equals to 0, right? A equals to 0, it means what? You can say that what, this must be what, this is x, right? You can write this also. Okay, now let us move on the next equation, the third equation, right? So here by this equation we can say that objects are in what? Displacement with average velocity, right? We can say that here, from here also, t equals to, can we write v minus v naught by a also from this equation? From, you can say, this was the first one from equation first. Yes or no? Right? Also, now from here also we can get that x equals to v average by t, and v average is what? v plus v naught by 2. Yes or no? Right? And t, this is v we have replaced, and t, this is t, so can we write it as v naught by a? This also we can write. Yes or no? Here v naught, v dash equals to what? V plus v naught by 2. This is what we have. This is what we have. We have just used these two right here. Okay, now if you further simplify it, x equals to, you know that this is what v plus v naught, v minus v naught by 2a, right? Now if you further simplify it, so you can get it as what, 2ax equals to v square minus v naught square. Cannot be right, can't be right. Or at the final stage you can write it this one as what, v square equals to v naught square plus 2ax, and this is your third equation, right? So I hope you get this all. Okay, in the next lecture we'll see the next new topic regarding this only. So thank you for now.